Hey guys, so in this video, we're going to review the techniques to solve different systems of linear equations, and I'm specifically just going to focus on one solution just to keep things easy so we can just focus in on the solving techniques. So systems, when I talk about systems, systems of linear equations, so they're going to be in terms of, they're not going to have any squared terms in them. Okay, well, we can simplify that. You can have as many variables as you want, and you can have as many equations as you want. So here's a linear system, 2 variables, 2 equations, 3 variables. You can really mix this up however you want though. And so a solution of a system is going to be what is true in both, well, in all equations at the same time. So that's what we're looking for. And so in this video, I just want to remind you of the main solving strategies for these. And then I have another video where we'll talk about what happens when you have like infinite solutions. So, okay, so first we have the substitution method. And so I like this system because there's a lot of different ways we can really go at it. So the idea with the substitution method is that in an ideal world, there would be an easiest variable to solve for. And so I'm assuming that you've seen this before, so you kind of remember this. So when I look at the system in its entirety, which variable would be the easiest to solve for? This x, right? So when that is super easy, then that is kind of like what might lead you to choose substitution. So to solve for x, I'm going to subtract off the 3y. So this equation now becomes x equals 12 minus 3y. And so then the idea behind substitution, it's really in the name, right? Now that I have solved this, I want to substitute it into the x of the other equation. So this whole thing, I'm going to take into the spot of the x right here in the other equation. So if I set that up, it's going to look like this. 3 times 12 minus 3y minus y equals negative 4. And so now you can see that I have an equation, right, all in terms of y, and so I can just solve this for y. So I'm just going to go about my business. 36 minus 9y minus y equals negative 4. And then it's 36 minus 10y equals negative 4. So I can subtract off the 36. So I get negative 10y equals negative 40. And if I divide both sides by negative 10, I get y equals 4. Okay, cool. So now what do I do with that? Then I use this result to solve for the x, which is the other variable. So in this case, it doesn't matter where you want to substitute, by the way, that y equals 4. You can substitute it into any equation that you wish. So just to back up here for a second, you could substitute it in here, or in this original equation here. It doesn't matter what you substitute it into. So I think the easiest one to substitute into would be in this form of the equation here, but if you did it another way, you'd get the same answer. So I have x equals 12 minus 3 times 4. So it's x equals 12 minus 12. So x is going to equal 0. And so then a lot of times you want to write this as an ordered pair, and you write it in alphabetical order. So x comma y. So my solution, maybe I'll just write it here, solution is 0 comma 4. That would be my solution. And you can check that by substituting this back into the original equations and just making sure that it's true. Now I want to contrast that to the elimination method. So using the exact same system, we know what answer we should get. The elimination method says, so usually what you do with the elimination method is you manipulate one or both equations. And ideally what you're looking for is you want to have, so like in this case, if I have plus 3y here, I would want the opposite here. Or if I have plus 3x here, I would want the opposite here, i.e. minus 3x. So it doesn't matter which way you want to go with this. So I just think that the easiest way to approach this would be to multiply this first equation times 3. So I'm going to restate this system now. If I multiply everything in that equation by 3, I get 9x minus 3y equals negative 12. And then my other equation is still x plus 3y equals 12. And so this is the ideal form of what you're looking for. You want this positive negative relationship between your variables, because then what do you do after that? Well, then you just add everything down. So 9x plus x is 10x. The whole point of this was for the y's to cancel out. And then negative 12 plus 12 is 0. So I'm left now with 10x equals 0, so I can solve for x. So if I divide both sides by 10, 0 divided by 10 is just 0. So I get x equals 0. That's what we found before, right? So that's not surprising. And then I'm going to do the same thing. I'm going to substitute this result back into one of the original equations. So let's put the 0 into this form of the equation. So if I have 0 plus 3y equals 12, this just becomes 3y equals 12. So if I divide both sides by 3, I get y equals 4. And so look, I get the same solution again, 0, 4. So I chose to use both methods just to show you it doesn't matter which one you want to use. I probably just end up using elimination method. I just like it better. I feel like it's faster. But tomato, it doesn't matter which one that you use. Okay, so the other thing I want to review with this is a common thing that can happen in systems, or you can have fractions like we have here. And so just a reminder, do not suffer endlessly for this, okay? Do not move forward like this. Clear the fractions. That is like, I can't emphasize that enough. So what I'm going to do is I'm going to multiply. So I have to find the LCD of each equation. So maybe I'll start here. So the first equation has an LCD of, so I have 1/2 and 1/3. So the LCD between those two fractions is 6. And then for this other equation, so I'll do the same thing. So notice I've got 3/2, just 3/2 and 3/2. So the LCD in this case is 2. So the first thing I want to do before I do anything else is I want to clear the fractions. So what I'm going to do is I'm going to multiply each equation by its respective LCD. Okay, and so if I do that, so 1/2 of 6 is just going to leave me with 3, so it's 3x. And 1/3 times 6 is going to leave me with 2, so it's 2y. And then don't forget 4 times 6, you have to multiply everything, so it's going to equal 24. And then when I come to this equation here, so now 3/2 x times 2 is just going to cancel out the denominator, right? So I'm left with 3x plus 3y equals 30. So clear the fractions first so that you can assess the situation. And now I would challenge you to finish this on your own and hit play when you're ready, just to get a little practice with this. Okay, so I'm going to go ahead and solve this now, and I need to manipulate this. And it doesn't matter which equation you decide to do this to. I'm just going to multiply this equation times -1. So I get negative 3x minus 2y equals negative 24, and then 3x plus 3y equals 30. So I can add these straight down, and what this is going to leave me with, the x's drop out, this becomes y equals 6. And that's cool. I don't have to do anything else. Okay, so now I just have to plug this back in. And now you might be saying, oh man, I don't want to have to plug this number back into the original equations. So the thing you want to remember with this, these equations are equivalent to the simpler equation. These are the same thing in math. This and this are the same thing. There's no difference between them. And I would much rather work with one of these two equations than all the fractions. So plug that number back into anything that's equivalent. So I'm going to plug it into, I don't know, let's plug it into the first equation. So let's call this 3x plus 2 times 6 equals 24. So let's just work that out. So this becomes 3x plus 12 equals 24. I can 24. I can subtract off the 12, so I get 3x equals 12, and if I divide both sides by 3, I get x equals 4. And so my solution in this case then is 4, 6. Okay, so I want to end this video with a review of one of the harder type of systems to solve, and I'm just going to do one of these because these take a while to get through. I will say though, if you want to see more examples of this, I will have another example video so you can watch more of these if you need. Okay, so with systems of 3 equations, the way I think about it is you're trying to take all of this and you're trying to boil it down to 2 equations in 2 variables. That's your ideal outcome with this. This is a little messy. So what you want to do, and I'll put some notes down as we go along this, and I would recommend, like, if you really struggle with this, I would recommend kind of writing the notes down alongside of this so that you have a reference for later. Okay, so the first step is you want to choose one equation to clear the same variable in the other 2 equations. So what do I mean by that? Okay, so look at what we've got here. Ideally, what will happen is you have a variable that you could easily eliminate twice. So I'm looking at the y's here because this positive y and this negative y, that's going to drop the y's out. Same thing here. This y plus the third equation is going to drop the y's out. Now, sometimes you have to manipulate these equations to make that happen, but it just so happens in this example that this works out nicely for us. So that's what we're going to do. Okay, so what I'm going to do is, let's see, I'll do this twice. So I'm going to take 2x plus y plus z equals 9 and negative x minus y plus z equals 1. So I'm just going to go ahead and eliminate the y. So that's going to leave me with x plus 2z equals 10. There's my first equation, okay? And now we'll pivot and we'll do it again. I'm using that same equation, 2x plus y plus z equals 9. So remember, you're trying to eliminate the same variable. So the third equation, which variable do I want to eliminate? I want it to be y. So if I go ahead and I eliminate, I'm left with 5x plus 2z equals 18. And so this is the ideal situation that we're looking for. So this is kind of like where you can take a moment and say, oh, okay, I understand. Like take a moment to pause and appreciate what we're doing. If you just try to memorize this process, it doesn't make any sense. But look at what I did. By eliminating the same variable, I am left with 2 equations and 2 variables. And that's all we've been doing in this video, right? So that's why we do that, so that we can get down to 2 equations and 2 variables, and then you just go forward with it like you always would. So, okay, let me clear some space. So there's what I'm left with. So now, using the leftover equations, we want to solve the system created by the leftover equations. Okay, so what I'm going to do is I'm going to have x plus 2z equals 10 and 5x plus 2z equals 18. And this is great because we can pretty easily eliminate here, right? So I can just multiply this first equation by -1 so that this becomes negative x minus 2z equals negative 10, and then I still have 5x plus 2z equals 18. Now, one thing that I want to note here is just notice how I continue to restate the system. It's very tempting because, like, I know it's a lot of stuff to write down, and it becomes really tempting to get sloppy and to have an equation here or there or whatever. Like, keep restating that system so that it's very clear what you're working on. If you don't do that, it can be very easy to get lost in your work. And, you know, there's just so many numbers flying around with this. You make one wrong move, you're going to get the whole thing wrong. Okay, so let's go ahead and eliminate. So I'm left with 4x equals 8. So if I divide both sides by 4, I get x equals 2. Cool. So we can solve this system, this original system that we have. I've got x equals 2. I'll note that over here so I can clear some space. So let me clear some space. Okay, so I have x equals 2. I can just go full steam ahead with finishing like the solution for this. So I'm going to plug this into the second equation. So 5 times 2 plus 2z equals 18. So I have 10 plus 2z equals 18. Subtract the 10. So I get 2z equals 8. Divide both sides by 2, and I get z equals 4. Okay, so now I've got x equals 2 and z equals 4. So let's go back to that original system now with those 2 solutions. Okay, so this is where we started. We solved the new system and we found x equals 2 and z equals 4. So look, what do I have left to solve for? I just have to solve for y, and now I can refer back to any one of these equations to do that. So I'll just use the first equation. So I have 2 times 2 plus y plus 4 equals 9. So this becomes 4 plus y plus 4 equals 9. So I have 8 plus y equals 9. So if I subtract off the 8, I get y equals 1. And so my solution then is 2, 1, and 4. Okay, and so there's the idea behind that. So I don't want this video to get too long, so I'm just going to do one of those, but I'll just remind you, if you want to see more examples of that, I will have some example videos of just the 3 systems, so you can check those out. All right, guys, so I'll catch you in the next video. Thanks for watching.